Alright, in this video we're going to look at potential divider. Before we start off with this, imagine there's one day that you wanted to light up a lamp, but you don't have the exact values of the EMF that you want. You only have a 12 volt battery, but you want only 6 volt to light up the lamp. Okay, so you can't cut the battery into half, right? So what you need is that you need a circuit to get half of the volt or half of the EMF provided by your 12 volt battery. So you're going to get 6 volt for your lamp only. Okay, so to do that, that's where this potential divider circuit comes in. Okay, so we start off with that. So basically you need a series of resistors. Okay, you need a series of resistors so that they divide the potential, the EMF of the battery. So if you want your half of the EMF of your battery, so you pick two resistors of the same resistance, and after that each of the resistors, they will actually take half, just half of your EMF. So each of them will take 6 volt and the other takes 6 volt, and therefore afterwards what you can do is that you just connect your lamp across one of the resistors. So say this is 12 and then you get 6 volts here. So that's how you get your 6 volt. Okay, since you cannot cut your battery into half and you only have one battery. Alright, so that's the overall idea here. Okay, so potential divider circuit basically has a battery and it has a series of resistors. Alright, so we are going to now look at how to get the equation to calculate the PD across one of the resistor or part of the resistance in that series. So the overall idea is to get rid of the calculation of the current. Alright, let's start with that. To get the equation. So first of all, we have E equals to I R1 plus R2, and we rearrange into I equals to E over R1 plus R2. Let's say we want to find the V across the R1. So what we have is V1 equals to IR1, V1 equals IR1, and from the current just now that we have rearranged into this in terms of the EMF, now we sub the I here with this, then we get this longer version. So the good thing is that we get rid of the current. Now you might not see the convenience of that, so when it comes to the question, it will be very handy here. So at the end we have I rearranged it so that the R1 now is moved inside here, the E has been moved outside. It won't change the equation, I just move them around. Okay, so what I want you to see here is that V1 basically is the ratio of its resistance to the total. Okay, ratio of its resistance to the total in the series, and then you use that ratio, you multiply by the EMF. So this portion here of this resistance, when you multiply by the EMF, you should get the V1. So that's the same idea just now, that we have the two resistors that are the same value, right? So because each of them is the same value, so when you connect the V1 across one of the resistor, you get half, because it's what R divided by 2R. So that's why it's the 6 volt in the case that I mentioned just now. Okay, so let's see whether it works for the R2 on the other side. V equals R2, V2 equals to IR2, and we sub back the same value of the current, the expansion of the current inside here, and at the end when we rearrange that, you get R2 divided by the total. So that's the difference that you can see, okay, between the two V1 and V2. So whenever you want to get a potential difference of one resistor, you just take its resistance, divide by the total. Okay, so that's how it works. Okay, now let's look at one example here. We have a battery of E, and then it has R1, R2, and R3, 5 volt, 5 ohm, 10 ohm, and 15 ohm. Okay, what is the equivalent resistance? Equivalent resistance also means total resistance. So of course it's the total of this, all this, yeah. That's a 20. No, sorry, 30. Okay. Use potential divider rule. Potential divider rule, the equation that you learned just now, to find the voltage drop across each resistor. Voltage drop also means potential difference, because the voltage will drop as it go. So let's say here 0.3. So it will drop to a lower value, then drop to a lower value, then it drop to 0. Okay, so we're going to find out the potential drop, which is the potential difference also. All right. Okay, so let's say the first one is 5 ohm. We're going to find the V1 here. What you can get is you use the resistor of that resistance of that resistor divided by 30, and then you multiply by 0.3. Okay, so you do the same thing for the rest, then you should get this answer here. Okay, so I'll see you in the next video.